Okay, page 174. So we are doing the exponential differentiation or differentiating the exponential functions. These are simple things. What we need to remember is the chain rule. Primarily the chain rule and UV, U by V, product rule, quotient rule. What we need to remember, what do we mean by chain rule? We know the differentiation of e power x is e power x. But if I have differentiation of e power 3x, for example, then first write for e power 3x, then differentiate this 3x, so we'll get 3. So 3 e power 3x. So this is what the chain rule will be using it here. Okay. So first question, differentiate the following with respect to x. E power x divided by sine x. So u by v, so u equal to e power x, therefore u dash is e power x only. V equal to sine x, v dash equals to cos x. So then differentiation of this, we'll say let y is equal to this, dy by dx equal to v squared u dash v minus uv dash. So u dash v, that's e power x sine x minus uv dash e power x cos x divided by v squared, v is a sine x, so sine squared x. So that's the dy by dx. If you want, you can take e power x common here, so you get sine x minus cos x whole divided by sine squared x. That's the end of it. It's done. So we go to the next question. Second question, e power sine inverse x. So always assume that y is equal to e to the power of sine inverse x. So two methods. Again you have two methods. Let's do method 1. Dy by dx equal to, so e power anything, first you do e power same sine inverse x multiplied by, this is the chain rule, d by dx of sine inverse x. So e power sine inverse x multiplied by, just now we completed the inverse trigonometric, we got that and asked you to remember also the formula. This is it. So in exam, can I do like this only? I memorize the formula and write it. Yes, of course. You, if it's a 2 marks question, you don't again do the differentiation of sine inverse x here. Okay. So the answer is e power sine inverse x divided by square root of 1 minus x squared. This is the answer, first one. If I have to do the second method, okay, y is equal to sine inverse x, e power sine inverse x so let sine inverse x is equal to something t, then sine t is equal to x, then differentiate, you will have cos t equal to dx by dt. So now substitute here, y is equal to e power t. So you want dy by dx, it is dy by dt into dt by dx. Dy by dt is e power t only, same thing, multiplied by dt by dx is 1 by this, 1 by cos t. So e power t, t is nothing but sine inverse x, divided by cos t is nothing but square root of 1 minus sine square t. So you will have e power sine inverse x divided by square root of 1 minus sine inverse sine, this is sine square t, that is x squared. So you get the same result. Same result you will have. Okay. So any method you can do in exam, whichever method you feel good and easy, that's the one you should follow, and you will get full marks either way. So the next one is e power x cube, right? That one, yeah. Third question in the textbook. I am reading the textbook. So y is equal to e power x cube. So I am doing the method 1. So dy by dx equal to e to the power of x cube into differentiation of x cube. That's equal to differentiation of x cube is 3x square into e power x cube. So that's it, one step. Since it is just one step, you may get this in a 1 mark question also. So the next is sine tan inverse e power minus x. Sine tan inverse e power minus x. So dy by dx. First what you are seeing is a sine. So for that it will be cos. Write down the entire thing. Tan inverse e power minus x. And you start differentiating this. Dy by dx of tan inverse e power minus x. So write down the next step. That's equal to cos tan inverse e power minus x, and for this you are looking at tan inverse. So the formula is 1 by 1 plus whatever is here square. That means e power minus x whole squared, and then differentiate e power minus x. Okay. So the chain means this is how the chain coming, d by dx keep on coming. Okay. So that's equal to, so the first part is anyway cos tan inverse e power minus x, which we have done already, and this part would be 1 by 1 plus e power minus 2x. When you multiply with the exponent you get that. This is e power minus x multiplied by minus 1. For x you differentiate, you get minus 1. So that is the final answer. So minus e power minus x into cos inverse. Okay, I will write in the next page. Okay, so you have this entire thing minus e power minus x divided by minus e power minus x divided by 1 plus e power minus 2x into cos tan inverse e power minus 2x. This is the answer. Okay, so the next question is log cos e power x. Y is equal to log cos e power x. So dy by dx is, for log, whatever you have, 1 by this, 1 by cos e power x, and differentiation of cos e power x, differentiation of cos e power x. So that's equal to, this you can write it as secant e power x, differentiation of cos you are seeing, minus sine e power x into differentiation of e power x. So this is minus, I think we should have retained that anyway, minus sine e power x divided by cos e power x, you get tan e power x, and for this e power x. So the answer is minus e power x into tan e power x. That's the answer. Okay. Sixth question. You are understanding, right? Okay. Sixth question. You have up to x to the power of 5, I think. Square x to the power of 5 or 4? What is that? X to the power of 5, right? E power x square, y is equal to e power x plus e power x squared plus e power x cube plus e power x to the power of 4 plus e power x to the power of 5. So whenever you see plus here, or minus for that matter, you do the differentiation of each of them. That means you consider this is one, another function, and so d e power x by dx is e power x. Then you do d e power x square by e power d of x is nothing but e power x square into 2x. So for the next one you will have 3x square. So the answer will be e power x, that's for the first one. For the second one, 2x e power x square. And for the third one, 3x square e power x cube. For the fourth one, 4x cube e power x to the power of 4. And the last one, 5x to the power of 4 multiplied by e x to the power of 5. Have you understood this or no? Yeah, I just, I don't want to do each step because it's a simple one. That's why I gave this example. And for the next one, you will get 3x squared instead of 2x. For the next one, you will get 4x cubed. The next one, 5x to the power of 4. Otherwise, it's just simple. Okay. Yeah, it's easy question actually. Seventh one, d by dx of y is equal to square root of e power root of x. So dy by dx equal to, first one is the root. That means you have to say e root of x to the power of half, right? So this half will come in the front. Half minus 1, and then differentiation of this. So what we are seeing first is what is important. So this will go, this is minus 1, so you will have 1 by 2 root e power root x, that is for this part, and d by dx of this is e power root x and differentiation of root x. So differentiation of root x is nothing but 1 by 2 root x. So you will have e power root x divided by 2 square root of e power root x into 2 root x for this. Okay. This is also kind of you understood, or you want to repeat anything? If I give a question, you want to do that again or something? Not required, right? 8, 9, 10. We can complete this exercise easily. So 8th question, log x. So y is equal to log x. So if you want the other substitution method, I can try. Both mean same. Okay. So I'll do both methods for you here. Okay. Method 1. So y is equal to log x. So dy by dx equal to, for log it is 1 by whatever is here, log x, and whatever is this differentiation, d by dx of log x, that is this log x. Okay. So 1 by log x, and differentiation of log x is 1 by x. Therefore the answer is 1 by x log x. Method 2. Let t is equal to log x, because this is the extra thing. So dt by dx equal to 1 by x. dx by dt will be x. So from here y is equal to log t. So dy by dx equal to dy by dt into dt by dx. We need only dt by dx. So dy by dt is 1 by log t. Sorry, 1 by t. 1 by t into dt by dx is 1 by x. But t is equal to log x. Therefore, same answer. So the same answer, you have dy by dx equal to 1 by log x into 1 by x. You can do any of the methods. Okay, this is a direct chain rule. First method 1 is a direct chain rule. Method 2 is a substitution. I was recommending method 2 for some reason, because in integration also you will have a substitution. Okay, yeah. Then we have the next question. Cos x divided by log x. So u by v rule. U is equal to cos x. U dash is minus sin x. V is equal to log x. V dash equal to 1 by x. So dy by dx here will be v squared u dash v minus uv dash. So u dash v is this minus sin x log x minus uv dash is this 1 by x cos x divided by v squared is log x whole squared. So you just do the simplification, minus will be taken out and then x will come down. So you'll have x log x whole squared. Then this x multiplies here, x sin x log x plus cos x. That's it. Okay. Last one, cos log x plus e power x. Tenth one, y is equal to cos log x plus e power x. So here dy by dx is minus sine log x plus e power x into dy by dx of this part log x plus e power x. So minus sine log x plus e power x, and differentiation you will have for this differentiation 1 by x plus e power x. That's the answer. Okay, so you may want to simplify or you can leave it like that also. You'll have minus sine log x plus e power x divided by this x will come here into 1 plus x e power x. Actually both are same. We don't know whether it is simplified or complicated. We made it complicated, but both are almost same. So exponential and logarithmic differentiation. So the logarithmic differentiation, there are two parts again. When do we use a logarithmic differentiation? If we see the questions, there are two types of questions. One is you have the use of this in a multiplication or division. Okay, that means as a substitution or to simplify the uv rule and u dash v rule. Logarithmic differentiation. So what this means is, For example, whenever there is a product of functions f of x, g of x, h of x, k of x, like that, and you want to differentiate this, then you have method like first consider this as u and this as v. Again inside that you will have something, no, this one, this one, this one, this one. So 4 times you use the UV rule. In same way you have division also too much actually, like x minus 1 into x minus 2 into x minus 3 divided by 2x plus 3, 5x plus 2, whatever. So when you have to differentiate these things, it is complex and it will take a long time and more work also. So this is same as how the logarithms came into picture. So logarithms came into picture, like if you remember what they taught you in ICSE. If I have to multiply two numbers 2, 5, 4, 3, 7 multiplied by 7, 6, 8, 2 or 7, 2, these things, you do the hard multiplication, multiplying these two with all these things and all the stuff, or they use the log tables. So when you take a logarithm, you take log of whatever is the 25437 plus log of 76872. You do the plus by doing the logarithms. Okay. So the usage of logarithms is to simplify the multiplication into an addition of logarithms. And that's the reason I'll give an example how this logarithmic differentiation is used to simplify. Okay. Maybe we will do one question or two questions today and then stop. Okay. So let's suppose, what are the logarithmic rules? Let's look at logarithmic rules. If I have two functions or whatever, log m into n is nothing but log m plus log n. These are the ICSE rules. Okay. Log m divided by n, this is what you learnt at the time. Log m minus log n. And the third one is log m to the power of n equal to n log m. So we will be using initially these two to simplify our uv or u divided by v, to simplify these things. Okay, so look at the first question. The first question is y is equal to cos x into cos 2x into cos 3x. So what we do, we take log both sides. Taking log both sides is not differentiation, it's algebra. Okay, so it becomes log y equal to log cos x into cos 2x into cos 3x. So which one will apply? The first one here, log mn, right? So this is split as log cos x plus log cos 2x plus log cos 3x. Understood? Yeah, so I rewrite that. You have log y equal to log cos x plus log cos 2x plus log cos 3x. Now we want to differentiate LHS and RHS. So I write down this one like this and LHS differentiation. And this is RHS differentiation. So whenever log is there, you'll get 1 by y, and differentiation of y is dy by dx. And here log cos x, 1 by cos x, differentiation of cos x is minus sin x, plus 1 by cos 2x minus sine 2x, but then 2x is there, so multiplied by 2, plus 1 by cos 3x minus sine 3x into 3. So you have 1 by y dy by dx equal to minus sin x by cos x minus 2 sin 2x by cos 2x minus 3 sin 3x divided by cos 3x. Most of the time, in a hurry, we do up to this and we think we have completed it. No, there is a 1 by y here. So your final step is dy by dx equal to y into this entire thing, whatever is there on the top. And you have to substitute what is the y value. Y value is whatever is given in the question. So that translates into cos x into cos 2x into cos 3x and entire stuff. I'm a little lazy to write that, okay? So I just put a symbol there, okay? So this is how a product, instead of using a product rule, we are actually using a logarithm to differentiate this thing, and that's why this is called a logarithmic differentiation. Okay, so the next question, x minus 1 into x minus 2 divided by x minus 3, whatever, that is an example for a division. How do you use a simplified? So y is equal to square root of x minus 1 into x minus 2 divided by x minus 3, x minus 4, x minus 5. So this entire thing can be written as x minus 1 to the power of half to x minus 2 to the power of half, because square root will be coming to everything. X minus 3 to the power of half, x minus 4 to the power of half, x minus 5 to the power of half. Now take logarithm both sides. Log y equal to log of entire thing. So that simplifies to log y is equal to whatever is in the numerator will get added up. Half log x minus 1 plus half log x minus 2. Denominator ones by the m by n formula, minus half log x minus 3 minus half log x minus 4 minus half log x minus 5. Understood, right? So the half can be taken as a common. Yeah. So you'll have log y equal to half into whatever is the stuff. Okay. You got log x minus 1 plus log x minus 2 minus log x minus 3 and so on. So now differentiate with respect to x. 1 by y into dy by dx equal to half. You are differentiating each one. 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. So dy by dx equal to, this y will go other side, y by 2 into this entire thing. So now I substitute y back. That means y is nothing but square root of x minus 1 into x minus 2 divided by x minus 3 into x minus 4 x minus 5, and whatever is the remaining part. This entire remaining part will come here. Okay. So that's how the long answer. Remember I told you, right, this kind of questions will be given during your normal school exams because they want to test every unit you understood or not. But in the final board exam, it's very, very unlikely. That means very rarely they will give. Okay. So any doubts or questions or anything? No. Okay, so let's go back and do a quick revision. Okay, so we'll go to the what we covered today. We'll just do the quick revision. Okay, this is the first one. So we did up to sixth one in the last class in the exercise 5.3. So we took sine squared y plus cos xy equal to k. K is actually the constant called kappa. So its differentiation of that is 0. We did the left side differentiation, right side differentiation. So primarily the chain rule. For sine square y you got 2 sine y, and sine y differentiation is cos y, and y differentiation is dy by dx, chain rule. So like that we got left side and right side. We went ahead and we made the dy by dx as a subject, and therefore y sin xy divided by entire thing will come. Second question, sin squared x plus cos squared y equal to 1. So you do the left hand side differentiation, right hand side differentiation. Left hand side differentiation is 2 sin x cos x plus 2 cos y into minus sin y into dy by dx. So you take the things to the right side and then you do dy by dx. Either you could stop it as 2 sin x cos x divided by sin y cos y, 2 sin y cos y, or you can simplify that to sin 2x divided by sin 2y. So then I gave a little bit explanation on how we do the inverse trigonometric functions differentiation. Y is equal to sin inverse x, and this you understood pretty well because you have done cos inverse x and tan inverse x. Okay. So we started saying the two methods are available. One is substitution method, x is equal to tan theta, or you go in the long method without substitution. So in questions 9 to 15, I recommended using the substitution method. X equal to tan theta, dx by d theta you get, and everything you write in 1 plus x square. So y is equal to sin inverse 2 tan theta by 1 plus tan square theta, but this 2 tan theta by 1 plus tan square theta is nothing but sin 2 theta. That's how y equal to 2 theta. I think this set of questions also you understood decently. So yeah, we went ahead with this 3x. Then I told you that this is a formula. You may get the tan 3 theta. That's why we went ahead. Y equal to 3 theta. You got 3 by 1 plus x square. Actually, if you understand the concept, it's very easy to revise these things. Okay. So in fact, if you don't do inverse trigonometry, it looks actually much tougher. Okay. So we continued the next question. 12th I gave a hint, 90 minus 2 theta. For 90 you get 0, and the 13th also similar, you get 90 minus 2 theta. 14th we did it. 14th is like secant 1 by cos theta will come, d theta by dx. So you substitute, you get the same easy one. 15th one I think we are using this cos 2 theta formula, and that's what we substituted into secant inverse 1 by something. So you got secant inverse secant 2 theta. Again y is equal to 2 theta we got. We simplify in the same way, differentiate and simplify. So 5.4 is the exponential thing. This is about primarily the chain rule, uv and u by v. So this is much simpler exercise. This question I don't need to explain. This question I don't need to explain. All easy. Only this one, x cube or there, then you got 3x square e power x cube. So fourth one you got two chains are there. For the first chain you just said for sine you just cos, you retain everything like that only. Whenever you are applying chain rule you just retain that. Then you differentiate this tan inverse e power minus x. So when you are doing that you get 1 by 1 plus x square. I remember the formula, that's what I used it. Then differentiate this e power minus x, and that's how you get it finally. So the next question, yeah, I really rushed it up and you said kind of little bit understood but not fully, but I think once you revise you'll be able to understand this. Completely chain rule. All these questions are chain rule. This exercise stands to get a 2-mark question definitely, this exercise when compared to logarithm, but you will have questions from both. Okay, One can come as a 1 mark question, other can come as a 2 mark question. Okay, so both exercises are important. So from the logarithm perspective, this is log, I think this is still in the same exercise, so you just do the chain rule. Okay, ninth one also similar, that's the last question in that exercise. Logarithmic differentiation, I just mentioned that whenever you want to simplify the uv or u by v, you will use that logarithmic first logarithm, take logarithm both sides, then differentiate both sides. So use these three rules. Okay, this rule also we have used. So the first question is very easy using the first rule. Okay. Then the next question was onto, you are using that half also, that means you are using all the three. First mn also, m by n and m to the power of n. All the three of the logarithms we use, and then you do the differentiation both sides. I did not write the full thing. When you are actually writing in exam, of course you have to write. Okay, you can't put these arrows. Okay, so that's how we did. Now, so with that we completed up to the second question. So third question onwards we will do, but as I said, the questions number in fact 8 onwards will take long time. Up to 8 we will do really fast. 8 onwards each question will take a long time. Okay, long and very lengthy thing. We'll try to complete as much as possible by Friday. Hopefully next week we'll have the other subject. Okay, all right.